Hi, and welcome to the Worldwide Center of Math Thanksgiving-themed Thank Thursday problem. In this problem, a mathematician invites his other math colleagues over for Thanksgiving, but before they can get up to get their food, they first have to solve this math Alphametic, which is Thanksgiving-themed. So each one has to solve it, and then they can get their food and celebrate. So to begin, what the problem is the word feast plus the word full is equal to turkey. And if you've never solved an Alphametic before, it's important to note that the two rules of solving them are that each letter can be dictated by one of these numbers from 0 to 9. And if the letter is used more than once, it must be used by that same digit. So each letter corresponds to one single digit, and no two can be the same. Also, when you're done solving it and you've replaced all of the letters by digits, it should come out to be a true addition problem. So this problem should end up coming out to be completely true in terms of the actual addition of whatever number this is plus the second number is equal to turkey. So now we're going to begin. So one of the other kind of general rules of Alphametics is that if you have two summonds and what they add up to is actually one digit longer than both of them, this digit has to be a carried over 1 from the next column. So this t right here, we automatically know actually has to be equal to 1. Now we can move on to the next column, this column right here, and you'll notice that it's actually f plus 0 is equal to u. And really what that tells us is that to make this part of the equation true, that we have a carried over 1, you'll notice that u has to actually be equal to 0, and we have to have f equal to 9. And then we would assume that in this row, e plus f is equal to r. We get some number greater than 10 that carries over a 1 to make this part of the equation true. So immediately we know that f is equal to 9 and that u is equal to 0. And I just added here on top of this row, 9 plus 0 is equal to 0 with the carried over 1, so equals to 10, that we know that there's an addition of a carried over 1 from this column next to it. So now looking at the next column, a plus 0 is equal to k, what you'll notice is that we know that there has to be some kind of carried over 1 from the column before it, s plus l is equal to e, because in this column we don't have a plus 0 is equal to a. In that case, we would know then that a is some unique number, obviously, but since a plus 0 is equal to k, some different number, we know there has to be another carried over 1 here. And looking at the remainder of numbers that we could possibly use for a, you'll notice that the greatest number we can actually take is 8. And keeping that in mind, if we had a equal to 8, what we would get is 8 plus the carried over 1, 9 plus 0 is only equal to 9, so it can't be greater than 10. So what that really tells us is in this row, e plus 9 equals r, that there's not a carried over 1, that this column stays by itself. And what that tells us is that from the remaining values of digits that we could substitute in for e and r, you can do kind of a guess and check method, checking them all until one of the combinations ends up working out. So to begin, I'm just going to start at the top and show you a few different examples, but since there are so many numbers, what you can do is go through and guess and check them all, but you'll end up coming out with kind of the same issue where in each case it's impossible. You use a digit that you've already dedicated to one letter, and it's impossible therefore to use that digit again, and until you actually get the correct substitution for e, all of the other possibilities are impossible. So to begin, if we just assume that e is equal to 2 and r is equal to 1, what you'll notice immediately is there's no way that r can actually be equal to 1, as we've already said that t must equal 1. So right away, that option for e is impossible. And we can also do a similar thing working back up. So let's say that E is equal to 8, which would mean R is equal to 7. So obviously, if E is equal to 8, we can see here that R must be equal to 7. Just 8 plus 9 is equal to 17 with the carried over 1 that we know is already there. But the way that we can tell that this kind of solution is impossible is that looking at this column, S plus L is equal to 8. We already know from before that there has to be a carried over 1, so we know that S plus L actually has to equal 18. And there's no way for us to actually make that equation true with the digits 0 through 9. 9 obviously we've already said is equal to F, so there's no way for us to actually make this part of the equation true. S plus L is equal to 18. So going back to where we were guessing for E, what we can do now is I'm just going to show you what the correct guess for E is. So the correct guess is that E is 3, which would make R 2. And filling those in, you'll see why that actually ends up coming out to the correct answer. So filling in E equal to 3 and R equal to 2, you'll notice that this part of the equation is true. 3 plus 9 is equal to 12. We carry over the 1. That makes the rest of the equation correct. And then for the rest of it, what you'll notice is that S plus L is equal to 13. And what we can technically see from there is that S plus L has to be some combination of 6 and 7. 6 plus 7 is equal to 13. We don't know specifically which numbers are which, so we don't know if S is equal to 6 or if S is equal to 7, but we know that those two, S plus L, have to be equal to some combination of 6 plus 7. And from there, it's pretty easy to fill in what the rest of the kind of equation would look like, and I'll kind of show you how to do that. So with the remaining choices for digits, what we can do is focus on this letter A. And you'll notice that from what we have left, the really only way to make A plus 0 equal to K, keeping in mind that there's a carried over 1, is if we have A equal to 4 and K equal to 5, which makes this equation true pretty obviously. 4 plus 1 is equal to 5, so you can fill that in. And continuing on, what you'll notice is the digits that we have left are 6, 7, and 8. And obviously from this first row, we have 1 plus L is equal to Y. It really only makes sense to have Y equal to 8, which means we must have L equal to 7, and S would be equal to 6. So filling in all the numbers, you'll see that this addition equation is actually completely true, and we've solved through. So we know that U is equal to 0, T is equal to 1, R is equal to 2, E is equal to 3, A is equal to 4, K is equal to 5, S is equal to 6, L is equal to 7, Y is equal to 8, and F is equal to 9. So that's all we have for you today for this week's Think Thursday. I hope you enjoyed watching it. Enjoy your own Thanksgiving, and check out some more of our videos on YouTube. Check us out on Facebook and follow us on Twitter. Thank you.